Hello, welcome to Infracoders number 33. That's right. Yes. We're at Kogan.com today. So, just show of hands, who is this first Infracoders? Awesome. That's quite a few. Welcome. And hello to people that have been here before. Like I said, we're at Kogan.com. This is our November meetup. I've got Goran over here that's just going to do his little 30-second talk about what Kogan is. Does anyone know what Kogan is or what Kogan isn't? No? Yeah, exactly. So, Goran?
Well, welcome everyone. Thanks for coming. We're really excited to host the event tonight. A lot of the things that get talked about at Infracoders and the challenges that get discussed at these meetups are things that we sort of face too, so it's really good to be part of the community. For those that don't know of Kogan.com, Kogan.com is one of Australia's largest online retailers. It's like, it sells things, it started off selling TVs and consumer electronics, but now we sell things to sports goods, hammocks, kitchen utensils, appliances, a whole range. So we, like as most people would probably read about us as a retail company, we're really like a tech company. So all our platforms are engineered in-house. We've built them ourselves. We host them on multi-cloud environments. So we have a lot of those issues with scaling and growing so quickly. And it's really exciting to be able to go and listen to some of the infrastructure and automation talks that we get to hear at meetups like this. Anyway, I hope you enjoy the food, the games, drinks, and the talks. And we hope to host a bit more of these in future. So hope to see you guys at other meetups and yeah, soon. Thanks.
Thanks, Ron. So we're going to do things a little bit differently tonight. We've only got one sort of scheduled talk. We normally have two. So at the end, while this talk's on as well, if you've got anything you want to sort of do like a lightning talk for like 5 minutes or so, we'll be asking for volunteers. So yes. And first up, we have Andy, who's going to do a talk on Riemann. So Andy.
Thanks. Right. Hopefully this project is just going to spring into action. The risk of sounding very vain, where do I stand?
Anyways.
Anyway, then, okay, cool. All right. Thank you very much for coming along, everyone. My name's Andy Marks. I work as a kind of technical person for ThoughtWorks. I also happen to run the DevOps Melbourne meetup group, or as Matt describes as the hand-wavy group that meets every other month rather than every month. And we've got a meetup next week as well, in case you're interested. And there's probably a big overlap between the people who come to Infracoders and DevOps anyway. So, much like a lot of the teachers you probably had at high school and second and primary school, I probably only know that much more than you do about what it is I'm going to talk about tonight. And for some of the kind of A students in the room here, you probably know more than I do. Okay. So that's my attempt at full disclosure. Bear with me. I have not played with Riemann in production. Okay, so I've used it quite a lot personally, done a lot of kind of tinkering with it to be able to generate this presentation, and other times I've spoken about it. But as far as kind of in the trenches, real war stories about how it works, how well it scales, where it actually falls over, what the boundaries are of its usage, I don't got those, so don't ask me any questions or he's going to get a sort of answer. There probably are people in the audience though who do use Riemann in production. Or not? No? Or not, okay. Or not is a valid answer to that as well. So, Riemann, and please resist the urge to pronounce it Riemann, even though that's the way it looks. It is apparently pronounced Riemann. It's interesting to me for a reason that's probably not overly interesting to you. I come very much from the coders part of the Infracoders world, and Riemann is written and is configured in a language called Clojure, which is a Lisp variant. Some of you who came through computer science degrees will have done probably some form of Lisp somewhere along the ways. Lots and lots of parentheses. Makes your kind of brain go a little bit weird if you look at them for too long. But I've done a lot of closure development recently, really like the language, and that was kind of my entry vector into Riemann, not really from an operations point of view at all. That said, I feel necessary to kind of credentialize it a little bit more than just because it's written in Clojure. And Riemann is put together by a gentleman, is it Carl Kingsbury? Someone? Kyle Kingsbury. Okay, so Kyle is interesting because above and beyond the fact that he's built Riemann, he also has another called Jepson or something like that, which is about testing systems tolerance under network partitioning, or the kind of P part of the CAP theorem. And he's also recently generated quite a lot of interest because he managed to prove, and I don't know the details of this, that RabbitMQ tends to vomit lots of data on the floor under certain partitioning circumstances. And I think he's on a similar path with Elasticsearch as well, although the Elasticsearch people are refusing to actually agree with his findings. But so he spends a lot of time in this sort of space. Riemann is one of his things. Kyle happens to go by the name of Aether on GitHub. Right, so this is a very, very kind of nebulous, generic definition for what Riemann is. The network event stream processing system, which basically means it could probably do anything that you want it to. It generally finds a home as a monitoring tool, or probably more realistically, a piece of software that you sit in the kind of pathway of all the data that you're generating in your environments, from your databases, your web servers, your applications, et cetera, and looks at that data as it comes past it and performs transformations or filtering or routing or forwarding on that data. That's kind of really what it's built for. And it's built for doing that in an environment where the data is coming from the network, from lots of different places. The demonstrations I'm going to show you tonight are not really going to be on a network. They're all going to be running on my local MacBooks. I'm going to need you guys to kind of suspend disbelief a little bit and imagine what it would be like if we were running in a far more sophisticated environment, but hopefully the idea is the same. Okay, so this is more or less how you can visualize Riemann. So we have a bunch of sources which generate events, and an event is really just something which is of interest, something that's happened in our infrastructure or in our environment, our architecture, that we want to know about. A web server responded to a HTTP request. A database completed a stored procedure call. An application allowed a new user to be registered. These are all events. They are not the same type of event, and they come from different parts in our system on the network, but they're all events. They're all things we probably want to be aware of, things that we often kind of stuff into our log files. All those events and CPU stats, disk stats, anything else you might want to think about that you could get from collectd or something like that can be sent through to Riemann for Riemann to kind of do its Riemann-y magic on, and we'll look at what that Riemann-y magic is later on, and then probably be kicked off somewhere else via an email or pager or dashboard or something else for kind of downstream consumption. So Riemann is very much a middleware tool for processing events. Okay? It's not, it doesn't play in the kind of UI visualization world, which is the way that a lot of those other tools do. Even though I'll show you a little bit of how it can do that as we go on. Right, so the objective tonight is really just to scratch the surface. Hopefully some of the stuff that I'll show you will interest you enough that you might want to go and do a little bit more research on your own. You might be interested enough in what Riemann does to want to explore it a bit further, but I'm not going to be able to go anywhere near a kind of suitable depth to allow you to start playing with Riemann in a serious way at the end of the kind of next 30 minutes or so. So really just scratching the surface. Okay, some key concepts. Now, unfortunately, I can't make this any bigger, so hopefully this is visible down the back. And am I audible down the back, by the way? Yeah? Okay, cool. So some key concepts here. So in this particular case, we have an Apache web server sending some events to Riemann, our big kind of golden sun in the sky. There's two main things here. This is conceptually what you can think of an event as being. It's a collection of fields that describe the event, describe the thing that you're interested in. And I put in some sample data there to show you what it might be for something coming out of an Apache log. So we have a host, the machine it's running on, we have a service, we have a state. It's got OK in there. You could probably read between the lines and see that that OK might be what's produced as a result of a 200 response code or some sort of 2 response code. It's got a time there, which is milliseconds since the epoch, since Jan 1, 1970. It's got a description, which in this case is /index.html. It's got a bunch of tags. It's got a metric, and I'll come back to what the metric actually is. And then it's got a time to live as well. So they are the standard fields that you tend to find when you're generating and sending events to Riemann. And you can, with a couple of exceptions, you are fairly free to put your own semantics onto what those fields actually mean. The host and the service, you probably want to leave alone. The time will get done for you. The time to live, ditto. But the other ones, like what goes in the description, what tags you use, what the state actually means, as someone who is configuring an environment to generate events to send to Riemann, you can choose what you want to represent in those fields. So I've kind of been fairly arbitrary in what I put in there. Different systems which generate Apache data into Riemann would potentially do it different ways. Okay. But an event is the key concept behind what Riemann processes, a stream of events. The other thing up here is what's called the index. Now you can mentally think of the index as being a table internal to Riemann, which has as a key, from a kind of like relational database key perspective, a host and the service. So these two things here form a composite key. And then the current event from that host and service pair. So the index keeps the most current set of events from each host service pair. It keeps them until they're processed, and we'll have a look at how we pull things off the index to process them, or it keeps them until they expire, because the time to live has expired as well. Okay. So two main things here, events, which end up going into the index until they're dealt with one way or the other. Questions at this point? Oh, boldly going. Okay. So for those of you who are familiar with closure or list syntax, this is kind of, broadly speaking, what an event looks like inside Riemann, internally. It's not exactly like that, but that's kind of more or less it. So again, the same fields that we saw before, the same values again, I think. If you're interested in how events get to Riemann, typically it's over TCP. You can also choose HTTP if you really want to. You can choose UDP if you don't care about the loss along the way. Irrespective of what protocol you use, everything's sent via protocol buffers. Okay, so reasonably compressed, reasonably high performant binary mechanism over the wire.
So do you instrument the Apache server with some kind of module that then passes it all?
Yes, yeah. And there are a bunch, and in fact, towards the end, I've got a list of a bunch of existing kind of event emitters for a bunch of systems, including Apache and a whole other things as well. Right. So, okay, time to do some demonstration. Now, what I'm going to do, I've got 5 demos here. Don't worry about the fact you may not be able to read this stuff. I'm going to show these again on subsequent slides. And the demos are all going to follow the same broad format. We're going to start by generating some events. Okay? I'm then going to update the configuration of the Riemann server that I have running on my machine, and it's going to be a different configuration for each of the demos. I'm then going to reload Riemann just so it recognizes that the configuration has changed. And then we're going to have a look at the results, have a look at what that configuration did to Riemann with the events that we have. Now, I need to talk about my events. To keep this presentation as simple as possible for me to do, and hopefully for you guys to understand, rather than set up a bunch of databases and web servers and message queues and other bits and pieces on my laptop to be able to generate a kind of more realistic set of events, I've cheated a little bit and I've created a little closure application that I'm going to kick off very soon that's going to traverse my file system and generate one event for each file it comes across. Okay, so you would never in a million years do this in a real production environment, but I just need to be able to create a reasonably deterministic set of events without going to too much configuration pain on my own machine to allow me to demonstrate the things I'm going to demonstrate. And the end result's the same. We've got events coming into Riemann, and they're events with the same sort of tags or same sort of fields we were looking at. Because I'm only generating events on my own machine, the host is always localhost. I've arbitrarily chosen the service name to be file size, and you'll see this text coming up again later on. The state I've chosen to represent whether it's a file or a directory, so we'll get both of those. Time, as I said before, the description is going to be the file name. the tags are filled with a reversed set of the paths leading to where that file is. Okay, so for this particular path up here, index.html is the description, and it's users, paymarks, code, Riemann. Okay. The metric, which is the key thing, which is it's a principal field because normally it contains the data that's really important to you, is the size of the file in bytes. Okay. And again, if this was database events that you're processing, it might be the time it took to execute the last database query. It might be how many rows were added over a certain period of time. It could be the response time from a web server or HTTP response codes, as we saw before, disk capacity, anything you can kind of think of. That actual number that you're interested in is typically what goes into the event tag or the event field. So I'm going to kick this off now. I need to have 5 terminals running here for reasons I'm going to explain. The size of the text should give you a rough guide as to where you should focus your eyes. Okay, I try to do it with colors, but I don't think that works. This is a Riemann log. So this is a Riemann log file which we're looking at here. We're going to see a bunch of stuff come up there fairly soon. I'm going to be updating my configuration, which is currently in Git, as we go through each demo down here. I'm going to be reloading Riemann here to kick it into realizing that it's got a new configuration. And up here in the top left is where I'm going to run the application to generate my events, which I'm going to do now. And hopefully there's nothing embarrassing in my file system that's going to pop up, especially for posterity. All right. Okay, so I'm going to start running that program. LEIN is just a shorthand for Linigan. Linigan is a build management tool for Clojure. Okay, so there's a lot of stuff that's running in Linigan. Yeah. Now, what it's doing is this over here is again traversing my file system from a particular point down. I think it's my code directory, spitting out all the file names that it comes across in our Riemann log. And again, it's not going to be synced perfectly because of buffering. It's going to actually show some of the events that we're generating. Okay, now I'm going to show you how that actually happens. Okay, so this is effectively the configuration we use for Riemann to show these things coming out here. Okay, to show these bits of information coming out in the Riemann log file. And I should mention at this point, these demos start out very, very basic. And they kind of build upon each other a little bit, so we get up to the point where it's something a little bit more probably really useful going forward. Now, for those of you who have worked in Lisp or Scheme or any kind of Lisp variant, Clojure included, you'll know exactly what that is. If you haven't worked in those sort of coding languages, which is probably a lot of us, this may not make a lot of sense. So I'll go through this as best I can. You might get a bit of a sense of it anyway. Basically, everything you want to process in Riemann tends to sit underneath this streams kind of pair here. Because this is a Lisp, the first thing you get after an opening left bracket is a function name. Okay, so streams is a function name here. Everything that's inside there is an argument to that streams function. But what this is saying is, when we have an event that we've got off the index, and the service is called file size, which is the sort of events that I'm creating, and it doesn't happen to have a .git tag in it because I'm not overly interested in all the things which are in my Git subdirectories, then I'm going to do all this. Okay. Now, I can talk in more detail about what that exactly means, but shorthand, this is a function which is going to print out the state, metric, extension, tags, and description fields of the event. Okay. Now, that's a lot of effort to basically just log an event coming in. But again, this is our first demo, so we're going to start off fairly basic and work our way up from there. So that PRN function is what's printing out these things here as we go through. Okay. So that makes sense so far? Okay. And again, generally speaking, you wouldn't just print things to the log file, you would forward them onto another system, or you'd do something to that data coming in. You'd mutate it, transform it in some sort of way, perform some calculation based on it perhaps. All of which are examples we're going to look at fairly soon. Okay, so if we're happy with that, I'm going to then go to our next demo. Okay, now, as I said right at the very beginning, Riemann is not positioned to be a visualization tool or a dashboard tool at all. That said, there is a application called Riemann Dash, which is a Sinatra or a lightweight Ruby-based web application, which comes not quite with Riemann, but is not too hard to find, which can give you the ability to do fairly basic visualization and create reasonably, and I'm not going to stretch as far as saying reasonably, adequate visualizations of some of the data you might want to look at. The author of Riemann Dash unadmittedly says, look, I'm not a UX customer experience sort of person. I understand this is not all that pretty, but it is useful. So what we're going to do now is we're going to take that same set of events, okay, which are our file events coming in, and we're going to have a look at how the Riemann Dash application can split the events based on something, by state. Okay. Okay, now, don't worry about any of this text. Actually, this will actually get bigger reasonably nicely. So this is Riemann Dash as it comes out of the box. One of the first things which might occur to you, and which indeed occurred to me, is if you were to try and turn that into a dashboard, it might be very difficult to work out how to do that. And indeed, it's not, even reading this, it's not immediately obvious what happens, but I'll show you basically what we do. So I've created a little tab here, and this tab has two kind of controls on it, or two portals, or two windows, call them what you will, one of which is streaming all the dir events, which are coming in through the index, the other of which is streaming all the file events. Okay? And you can see host name, service name, state, I think, size, and description there, those same fields. Okay. Now, the way it does that is you basically click on one of these and you hit E, of course, and it's going to give you a little configuration dialog. And all I've said here is state equals dir. So that's a little query which is filtering the events coming in based on the value in the state field. I'm happy to represent it as a log. There are other ways of representing data as well, and we'll have a look at a few more variations of that as we go along. Okay. But that's kind of, again, fairly basic stuff. Let's move on to the next example. So I'm going to change the configuration again. And I'm going to reload Riemann. So it recognises it's changed. And okay. What we're going to do here is we're going to read events in from the index as we have been with the other ones, but we're actually going to create new events as a result of that. We're going to inject some new events back into the index. And again, this is a really kind of dumb example, but I was trying to keep it as simple as I possibly could. And again, this is the key part of the Riemann configuration file that allows you to do that. If you were to actually open the Riemann config file, riemann.config, you would find a little bit more stuff, kind of top and bottom, but that other stuff which I haven't shown you is what you would have in pretty much any Riemann configuration. So what I'm showing you on the screen here is just the pertinent bits to the particular demonstration. So in our streams, as an argument to our streams function again, we're checking to see whether the service is file size, okay, as we were before. We're also checking to see whether the state is a file, and we're also checking to see whether the metric value, which if you remember is the size of the file in bytes, is greater than 6,000, just kind of cos, just to pick a value. And then when we find something that matches that condition, what we say is, let's create a new event, let's give it the name or the service name of big file, and let's inject that event back into the index. So we have an event coming in, which is a file, which is a big file. And then when we discover one of those big files, we create a new event and put it back in the index. So this could be like a first stage processing activity for something you want to do just on big files. And in the else condition, when those things aren't true, then we'll do the same thing, but we'll just call it small file instead. Now there's an actual logic error in here because directories are also going to be marked as small files, but don't worry about that just yet. Right, so that's what's happening. I've updated my configuration. I've reloaded Riemann. So that code is now running inside my Riemann instance here. If I go back to Riemann Dash, what I have here is another two controls. So at the bottom and the top, which is showing me a slightly different visualization on the file sizes of all the small files I'm reading in and all the file sizes of all the big files I'm reading in. Unfortunately, we don't have any big files at the moment. Hopefully one will come up soon or you'll think I've faked all this data out. There we go. So let's have a look at how we do that. And very similar to the last example. So it's a time series display, and the query we're using is just service equals big file. So we created the new event for the big files. We changed the service name to be big file, and this is just looking for all the events that come through with that particular service name. And not surprisingly, if we look at this one here, the service is a small file. Okay. Now, why you would want to graph file sizes over time like this, you probably wouldn't, but imagine the sort of real event data that you could be getting, and this sort of display is probably not too dissimilar to some of the dashboards that you may have in your environments at the moment. All right, let's go up another notch in terms of complexity. Okay, so the fourth version of my configuration, I'll reload Riemann again. Okay, so this is getting kind of one step towards being a little bit more useful. So Riemann has a bunch of built-in functions, because Clojure is a functional-based language, pretty much everything is a function, to be able to do typical sort of things you might want to do on event data coming into a system. And in this case, the function that we're using is one called percentiles. And what that does is it looks at the metrics of all the events that it's receiving, and in this case, it's all the small file events that it's getting, and it's going to generate the 25th, 50th, and 75th percentile values for those metrics, so for the file sizes, using a sample window of 5 seconds. Okay, so it's going to take a 5-second sample of all the small file events that come in, and it's going to generate the 25th, 50th, and 75th percentile. And this sort of percentile stuff is stuff we often do for response times at websites and database servers and things like that. It does one more thing as well, just kind of because I wanted to throw something else in here as well. What it does by generating percentiles is it'll actually generate new events again, similar to the last example, but a little bit less explicit. Out of this function call, there's going to be 3 new events generated. They're going to be called small file space 0.25, small file space 0.5, and small file space 0.75. So there's going to be 3 new events generated containing those percentile values. All 3 of those events are going to get kicked into the index for processing. And as we do that, we're going to take the metric, so we're going to take the file size, which is the size of the file in bytes, and we're going to scale it by 1,024. So basically going to turn it into kilobytes. Okay, I didn't really need to do that, that's what I wanted to play with that particular function. And it's going to pop that stuff back onto the index again. So over here, hopefully, in a couple of seconds, we'll see the visualization of those 3 new events. So we've got the 25th percentile, the 50th percentile, and the 75th percentile. So these are 3 different displays. They're called gauges. Down here is what's called a float, F-L-O-T. Don't know what it stands for. And this is showing, again, just kind of comparing them over time. And again, it's doing 5-second samples, so that's why this feels a little bit laggy. If you want to look at what's the logic that's behind each of these, okay, so that first graph, or that first gauge rather, is just looking for services which have the name file size 0.25. Because by convention, that's the name of that event that was generated out of percentiles. Okay, ditto for the other ones, just for the hell of it, 0.5. And I guess the more interesting one is the one down here, which says something slightly more tricky in that it's doing a regular expression match on any event that comes through with the service name, a file size, and then a 0 in there. So it's going to match on the 0.25, the 0.5, and the 0.75. That's how we get all 3 of those in that graph down the bottom. Okay. So this is kind of bordering on useful, I think. Of all the demos I've shown you so far, this is probably one of the ones that you might be able to immediately see how it could be a useful thing to actually have something like that. And you probably have something like that already with the tools you're using. All right, I have one more demo. Okay, so let's get the next version of our configuration file. Let's reload Riemann again. I like the fact that it says hyperspace core online when it reloads. See? And the last one is a little bit different than the one we saw previously, although it may look the same. One of the things about Clojure, and in fact about most functional programming languages, is that they are very terse. There's a lot of stuff in a little space. So if you're from a development background and you haven't worked with these sorts of languages, you might be used, especially if you come from a Java background or languages like that, to be able to have a lazy kind of glance over the code to slowly let the meaning of it kind of ebb in, because you normally have 100 or 200 lines to be able to read before you want to understand what's going on. With languages like Clojure, you have to be able to focus for far shorter, more intense periods, because there is so much stuff happening in a very small amount of code. But like the other ones, we're starting off the same way. We're filtering on file size, on the file size service, sorry, on events with the file size service. We're going to take the metric field out of that, and we're going to discard what it actually was, which was the file size, and we're just going to turn it into the value 1. Okay, so we're basically making it 1 every single time. And the reason we're doing that is because we want to calculate how many of these events we're getting in over a period per second. And the way we do that is we use this rate function. Okay, so the rate function takes, again, a sample window. So take a sample over 5 seconds with the data that's coming into it, which is our events with the metric set to 1. And then again, create a new event by taking the service name, which is going to be file size, and just adding the word rate on the end, and then kicking it back into the index. So that should give us the number of events that we're processing each second, that we're pulling off the index each second. Now, the code that I wrote to generate these events, because again, it's very deterministic, I put a ½ second sleep in between each event that's generated. So if this is working properly, we should get a value of 2, okay, or more or less 2, depending on how fast or slow things might be running at the time. So that's what's running in our remit at the moment, and it's in our last tab there. And again, take a couple of seconds for it to sample again. And there you go. Okay. Now, if I talk for just a little bit, you might see that, there we go. See, it's not hard-coded. It changed to something else. So it's not always going to be exactly 2, but it's going to be there or thereabouts. Now, there's a lot more stuff that Riemann can do, but I don't have the ability to be able to demonstrate here. I haven't really shown you how to connect it up to any kind of useful downstream processing systems just yet. I have an example that's going to do that fairly soon, and we'll show you a bit more of the breadth of the power. But one of the things that Kyle talks about in a presentation that I'm going to reference very shortly is that he's very much a fan of configuration as code, which is why he chose a full-blown programming language for the configuration system for Riemann. There is no other way to configure Riemann apart from writing Clojure code. That said, there are lots of examples out there of how to do particular things, and the snippets that I've shown so far are not terribly big, although it does take you a little while to wrap your head around exactly what's happening in each of those. But here's an example of something which is doing a lot, probably more than any of our other demos have so far. What this is doing, okay, ignore this first line just for a second. Here we've got our streams, and here we're saying, let's filter all the events that are coming in from the stream where the state is error, and when we find those events, let's do this thing called telops. Or if the streams have a tag of exception on them, we'll do the same thing, telops. And this thing here is, not surprisingly, that thing there. What this line does is it emails someone, okay, those events, but to avoid the possibility that you're going to be in an event storm where suddenly one of your applications has gone berserk or your web server's gone offline and you're getting a bazillion 404 or 500 errors coming through your Apache logs, it actually throttles those emails as well, which is what's happening here. So this throttle function, which comes with Riemann, says that over an hour or over a 3600-second period, send the first 5 events you get over that period, send an individual email to this person for each one of those events. Okay? So first event comes in, email goes out. Second event comes in, email goes out. Same for the 3rd, the 4th, the 5th. Any more events which are actually discovered in the remaining period up until the end of that 3600-second window all get batched up and sent in one email. So rather than, again, just spewing email after email or page after page at your poor ops person, or in this case, someone I work with at the moment, it will actually allows you to exert some control over to what degree you send out those emails. It's not a one-to-one correlation between detecting the event and sending the email out. It has some smarts in it via this throttle as well. Yes, I didn't have the ability to be able to kind of demo that in as we're going here, but this is just an example of some of the other things that you can do with something like Riemann. And it's an example of how you actually connect Riemann with the kind of downstream system. Yeah, and there's lots of other examples as well. So we spoke before about who can send stuff to Riemann. Well, there's a whole bunch that I managed to grab off the Riemann site. There's probably more custom kind of plugins and connectors or emitters, call them what you will, out there at the moment. But there are a whole bunch of ones there that I'm kind of modules at the moment that you can use to generate Riemann events from the stuff that they produce. There's also programming language bindings for most of the languages. I won't say all of them, but for most of the common languages you would probably find in environments, there's programming language bindings. I was using the Clojure binding to be able to generate the events for my demos. There's Ruby bindings, Java bindings, Golang bindings, probably Python, PHP, all that sort of stuff as well, if you want to be able to generate Riemann events that way.
I'm not seeing PostgreSQL as a SQLite.
Sorry, say again?
PostgreSQL.
Don't. No, right? Yeah, yeah, possibly not. Possibly not. Now, if what I've said, I'm really right at the end now. If what I've said is of interest to you and you kind of like the possibilities of what you can do with Riemann, or you just want to play for a little bit more, I thoroughly recommend you have a look at that video. That's Kyle, the author Kingsbury, talking about Riemann at a conference, I think from last year. It's not a high quality video. I mean, the content is very, very good. The actual image itself is a little bit fuzzy at times. So some of the slides are not all that clear, but he does a very good job in probably just as much time as I've spent standing here before you, describing the rationale behind Riemann and going through a bunch of examples. And he ends up with examples far, far more sophisticated than any of the ones I've actually looked at now. So, thank you very much for listening to me. I hope what I've said is of interest to you. Happy to take any questions that anyone may have. Subject to what I said at the start, which is I only know that much more than you do, I might go, eh.
And you mentioned the index a couple of times.
Yeah.
Can you describe what that is?
I'll go back because it's an interesting concept. So the index is this thing up here. So conceptually it's a table inside Riemann which holds the most recent event for each host and service. Okay. So an event comes in, it sits in the index, it stays there until it's either processed, in which case it comes off the index and the next event comes in, or until the event TTL kicks in and the event expires and Riemann will clear out the index. So you're not guaranteed, depending on how long it takes you to process the events, you're not guaranteed that you're going to actually be able to process every single event that comes in. If your processing time, if your ability to consume events off the index is far slower than the rate at which the events are coming into the index, is far slower than the TTL for those events, you're going to lose events. And likewise, if you're pushing stuff into the index far quicker than it can be consumed off the index, you're going to have issues as well. Now, Riemann will send an acknowledgement to all the clients that are sending events. So if you want to wait until you get an ACK back from Riemann to say, okay, my event's gone through, I can now send another one, you're welcome to do that. But I think most of the time, you probably want to be in a position where if you don't get every single event, it probably doesn't matter too much, I would imagine.
So there is no event management towards the index?
Well, the only event management is the time to live and your ability to be able to set up your kind of consumption of those events in a manner that will be faster than either the expiry or the rate at which the events come in.
So if you have events coming in like Maniac, you wouldn't have any queue there, just holding them up to go into.
No, yeah, that's right. That's right. Now, one of the other reasons why Riemann's written as Clojure is because like most functional languages, it places a great value in immutability and having immutable data structures, which means that you can process a lot of those things very, very quickly, especially if modern languages are like Clojure. But there is certainly a risk that if you overwhelm the Riemann server, then you're going to be losing events along the way. Sorry.
So can you recap on where it goes after it comes off your engine index? So
Oh, okay. So every one of those little bits of code that we were looking at consumes things off the index. Okay, so these things here, these filters here consume events off the index, and once they're gone, they're gone off the index. In some cases, we were re-injecting new events back into the index, but once you've effectively read them, that's it.
So you're going to have to come up with your own systems for doing anything with the data afterwards.
Yeah, and often it's a simple. I mean, it's not going to be a pass-through because there's no point doing it. All you're doing is passing things through. But often it's going to be a simple transformation or mutation or forwarding based on some values in the events, and it just goes off to the next kind of phase, which might be another system. It might be a Graphite dashboard, or it might be an email or something like that. But it's not meant to be a persistent data store. Okay.
It's not like doing something with the data when you send it where you really want it to go. Cool.
Yep, that's a very good way of thinking about it. Sorry, you had your hand up for a long while. I keep listening here.
I was just wondering
What sort of footprint?
Yeah.
So memory-wise?
Memory processing.
Yeah, I haven't looked into it, to be perfectly honest. So I'm not sure. Riemann, maybe not ironically, maybe a little bit ironically. Riemann is built to be able to consume things in a distributed environment, but Riemann itself cannot be distributed. Okay, so because you can do arbitrary processing on the events, it's not set up to be scaled out. So the idea is that you want to make sure that the processing you are doing is going to be okay for the sort of machine that you're running on. But I don't know. I'm not sure at what point it maxes out things or not. Because I can't imagine it's going to consume too much memory because, again, it's just processing one event at a time, more or less. CPU-wise, yeah, I'm not sure. That's one of my sort of answers.
So we've covered the index. On the other side of the index, when it's pulling things off of the actual index, is that just like, say, one agent that's pulling it?
Yes.
Okay, so it can always only be one agent.
Yes.
Okay.
Yeah, so that's what I'm saying. It won't. Well, look, that's.
From what you've said,
Yeah.
that's okay.
Yeah. I mean, if you're smart enough with what you're doing, you could potentially, and you're able to do the networking magic to get this to work, you could potentially manually shard Riemann processes if you made sure that the seams that you were sharding along actually were completely independent. And Kyle does talk about it a little bit in the documentation about how that can happen, but it hasn't been architected to do that. So it's effectively one agent pulling things off the index.
Because this is awesome to see this, but there's another tool that I found just recently. It's the Apache Kafka, which apparently does routing. Look, I haven't sit down and prototyped it, so I'm not sure like how more robust it is against this. But I'm happy to have two competitors now. Yeah, supposedly that does routing as well. So maybe it doesn't inject things like this, but you could send them to where you want them to be.
Yeah.
Without a single point, you know what I mean?
Okay, so that the example that we looked at where it did an email is effectively kind of forwarding onto another system. You can actually forward from one Riemann process to another Riemann process. Okay. So that there is a forward function which will allow you to do that. I haven't looked into how that works, but I know that can happen. Yeah.
So you could figuratively have sort of one step out of every 10 round robining to another room to.
Yeah, possibly. Yeah.
But then you have issues with when you start doing sampling. It's not a true sample.
Yeah. I mean, you certainly get sampling bias in those sort of situations, depending on how the traffic was being split up.
We haven't used this in vain, but one of our use cases we put in front of all the stuff that people want to use, like Graphite. It's not that good because then developers or whoever can just throw data at it, and then you can use your dashboard and just pull up that data and manipulate it, and then eventually you can roll that into the config that will ship it off to Graphite. Because you have these rolling windows of information that you kind of care about sometimes, but not all the time. So it's good to look at it. New features, signups or something like that, you can see it, and then you don't care about it once that's rolled into the product. So.
Here's another question.
You correlate multiple events and produce one event.
Correlate
Two or three things?
multiple events? Yep, yeah, you certainly can. So again, the data I had was only ever coming from a single service and from a single host. But there's no reason why these sort of where clauses couldn't include stuff from multiple hosts and multiple services. Okay, because normally that's what you'd want to do. You'd want to be looking to correlate a particular response time over here with an error over there or something like that. And you can do things also. Yeah, it just becomes a more advanced query.
So is the index something that's strictly FIFO, or can it actually be expected like in depth?
I believe it's strictly FIFO. Yep. I believe. Some degree of confidence. All right. Cool.
Why would you choose Riemann specifically over some other event processing framework or tool?
Because it's written in Clojure. Not the most compelling business argument, I grant you. And look, yeah, to be perfectly honest, that's, as I said at the beginning, that's why I kind of got into this. I haven't used, I don't know, equivalent-ish type tools, Kafka or other things like that, to be able to really make an apples and apples comparison. This just happens to be the one I've been playing with recently. So yeah, it's a poor response to that question, but in all honesty, it's my love of Clojure more than anything else. Yeah.
I'm sure it's a list of connected or agents or whatever
Yeah.
that are already there, and which is okay. All you want to do is process the output from some log. In the real world, you're more likely to want to write a custom agent of some kind. How difficult? What does it involve to create something that will talk to Riemann and feed events into it?
I'm glad you asked.
Does it have to be everything? Well, and that's the next bit.
So my one that generates the file events, that's it. So that's 39 lines of Clojure code. Again, it's not all overly smart. The key stuff is it's hooking into the Riemann Clojure library, so the language binding for Riemann is written in Clojure. Sorry, that contrast isn't terribly good. Send events, service name, state, metric, So I can't imagine it'll be any more difficult in other languages, perhaps slightly more verbose. But all I'm really doing here is I'm creating a TCP client, which is connecting to localhost and shipping those events off. Now, if I was more serious about this, and this is going to be production code, and depending on how many events I thought I'd be creating, I might want to be monitoring for the acknowledgement from Riemann that it's processed the event before I sent the next one, maybe. But maybe I just let the event fall on the ground, depending on what it was, how critical that information was.
So basically connecting to a local TCP call. I don't see the port number there.
Yeah, it's that TCP client is from the Riemann library. It's 5557 is the port number by default. I think 5556 or 7 or something like that. Yeah.
Is there any kind of performance, hand wavy, like how many events per second that has been achieved, like the correct or
No, I haven't. My machine's actually running reasonably warm, even with the half a second delay. Like it's still churning out files. It was running pretty hot before I had that sleep in there. So the sleep that I put in to space things out a bit, which is there, before I had that in there and it was just continually generating events, the machine was running pretty warm. So yeah, I don't know. I think the recommendations are use TCP as your first protocol of choice. Don't use UDP because unless you're happy with losing a lot more events. Don't ever use HTTP unless you're a crazy person. But yes, I don't know, I suppose, is the answer about how many you can push through. But it's going over the wire via a protocol buffer, which is going to be reasonably quick, especially going to the local machine. It's going to be very, very quick. If you're going over a network, obviously network latency is going to come into play there.
You didn't seem to be doing a lot of load when you had the dashboard up.
It shows the load, doesn't it? Yeah, yeah, it could very well be.
You're really sleeping.
No. Ah, yeah.
Just sort of general observation. I see this as a really useful tool for pre-processing for another system like Logstash and Splunk. One of the things I've seen with Splunk is that the event processing rules on ingestion are not all that flexible. But in terms of order operation and that sort of thing, whereas this it's all code, do whatever you want.
Yeah, you can pretty much do what you want. There's a lot of stuff built in, but yeah, you can do whatever you want with those events.
And similar for pulling events back out. So one of the problems I see with Splunk in particular is that real time. Everybody wants real time, right? For dashboards and things, but real time search is Splunk. So the same with CPU for every host that is sending data. But if you buffer that on the output.
Yeah. I mean, your comment about being a preprocessor is probably a really nice way of describing it, because it's not. I mean, it's not overly interesting just looking at stuff through the dashboard, but if you think of it as being the thing that gets your events into the shape for the next step of the journey, then that's probably where its sweet spot actually is. Yes.
Given that the config is in a first-class programming language, how easy is it to test drive the development of that?
So,
Do you test your
well, I was going to say I'm on tape. I'm on video here. My employer is going to hate me for saying this, but I didn't test drive this. Kyle, again, the author, talks a lot about it's being written to be testable. It's been written so that you can test the configurations that you have, so that you can stub out any timing sort of things that would normally make unit testing very unreliable. I haven't done that myself, but in theory it's possible. I mean, Clojure is a very easy language to test drive in general, or test drive or test after if you want to.
Any more questions?
Is there a limit of events that you can actually throw into it, like a range?
Look, I mean, conceptually, the limit is how quickly you can pull events off the index before they expire or before the next event comes in. So, and that will depend on the code you're writing to consume it and the machine it's running on.
And event recovery, is there any procedure for that? Like if you drop some events, will they be reflected into the index or no?
No, I think they're gone. Once they're gone, they're gone. Yeah.
But if I've got two chunks of code that are looking at the same event, both those chunks can get that done. Basically, one listener is like.
If you set up your configuration properly, you can pass the event off the index down through multiple nested bits of configuration that will all consume that. Yeah, I'm not sure exactly how that happens internally. Yes, yeah. All right.
Thanks, Andy.
Thanks, everyone. Thank you.
Does anyone have any lightning talks they want to do?
I'll do one.
Yes. Come down.
Andy, quick word, you don't go.
Oh. So normally I'd feel really guilty at this point because I'd be stopping everybody from getting pizza, but everybody's had pizza or, rolls and shit. So that's pretty good. So I'm going to talk about quite briefly, cool shit in Logstash. Now, who here is familiar with the elk stack? Cool, okay. Whoever's not familiar with the elk stack knows what I mean when I say Logstash. All right, so this will actually be surprising to a few people, which means that I should stay up here for a little bit longer. Now let's see if this connects. So you're gonna have to give me a second because I think my laptop will, no, it's actually got the real network now. So now I just have to go to displays. There we go. Mirror displays.
Awesome. Okay. So, fuck, that's make bigger. There we go. So, who knows how to get the magnifying glass on macOS? Come on, somebody.
Accessibility.
Really?
Yeah, it might be turned up. I think you just set a key to hold down and zoom.
Yeah, there's a key. There's a key.
Command scroll.
Command scroll. All right, everybody squints. Can we do that? Awesome. So, this is Kibana. Kibana is an interface on top of Elasticsearch. Elasticsearch is the most common destination for Logstash. One of things that Logstash does is it polls logs and sends them through to Elasticsearch in an indexable manner. Elasticsearch is a semi-schemaless data store. There's a lot of stuff in here that's going to be common with the Riemann, R-I-E-M-A-N-N talk previously, which is kind of what inspired me to do this lightning talk in the first place. So let's go Ruby on Rails, because we run Ruby on Rails at work. So one of the things I like to know is we've got a whole bunch of events over time, blah, blah, blah. That's pretty boring. We can see average performance, so we can see that it's usually around 150 to 200 milliseconds per request. That's okay for Ruby on Rails. I mean, it's, if you're using net, it's not great. That's from a day ago to a few seconds ago, blah, blah, blah. And the individual events down here, which are now being split out, I should be pointing at that, have all been split out. You can't see my laptop screen. Have all been split out into all the stuff that actually happened. So we can see here that it was a query for a that's a bike, isn't it? Yeah, thank you. I work for a bike company, but I've got no idea, right? And it was part of our search thing. Now, one of the things I really like to do is I really like removing code that isn't used, because I really hate code. I just like there to be less code. So what I can do with Logstash and Kibana is I can easily go, show me every time somebody has hit this route. By typing in the little query box there, and then hitting enter, and then I find out that I can't remove that one because it's our main search query. So, I might get in trouble. Yeah. But one of the other fun things I managed to do the other day, so just going to go just get it to show our Nginx logs, and I got told by my boss we're getting complaints of scammers going to our webpage and looking up the phone numbers of people listing private ads and then calling them up and sending, I will PayPal you the money right away as long as you send me this bike. And my pet theory was, we're getting hit from, I don't know, Nigeria or China or something like that. What I can do is in my Nginx thing, Logstash has a GeoIP function, which is really cool. And Kibana has a map display, which is also really cool. Now, if I make this really big, you can't see shit. Oh wait, no, there we go. So I got a map there. So I got no numbers, but you can see it's darker. So, there's normally numbers there. You can see that's not as dark, but there's normally numbers there. But anyway, pretend there's numbers. That's a big number. These are smaller numbers. So what I'm going to do now, reset it back to there, and I'm going to limit it to, so that's Nginx request, star, phone number, star. So show me everything that matches the phone number path. You can see my numbers reduce. And I can see, if I go down to the map, that I've still got lots of Australian stuff, but I've got a little bit of USA, I got a little bit of UK, and honestly, quite a lot of these PayPal scams come from the UK for some reason. And some Germany?
Yeah.
Yeah, thank you. And some
Geography lesson.
Nigeria? Is that Nigeria?
There's actually, from Nigeria to the UK, a really fat internet pipe, like an undersea cable.
Wow.
That's why you're probably showing up as Great Britain.
So there's a VoIP connection somewhere.
I didn't know that. I just thought.
It was on a documentary.
Oh, wow.
Like, let's make Nigeria good.
And
Nigeria. Hello, I'm Nigeria Prince.
Oh, that is awesome. This talk was totally worth doing just for that. and a little bit yada yada yada. And so we can see there's at least like at least a little bit of correlation there, which is pretty cool. And the whole reason for setting this thing up was just to be able to drill down into that kind of data really, really quickly and see these kind of correlations. The one caveat I will point out though is Logstash and Kibana, especially Logstash and Logstash Forwarder, is a complete pain in the ass to set up and get right. You do a lot of work. Alan sitting in the audience did a lot of work getting this together, and I did a fair bit of work getting it together, getting it reliable, yada yada. But every time there's a major problem where we have no idea what's going on, and the last thing you want to be doing is tail-effing log files and trying to let your internal brain pattern recognition see where all the errors lie. This is way better, even if I can't show it to you properly because I didn't prepare well enough. Thanks, everybody. Come ask me questions after if you have any.
Anyone else have lightning talk? No? That's cool. All right, go home.